All right, review for Unit 3, Test 4. Let's see. Okay, first one, simplify expression completely. That means distribute that 2 first. So 2 to the second z, because that's let's see, 2 to the 1 plus 2, and z to the 2. Oh wait, hang on. All right, it's on the outside of the parentheses, so we can multiply. So let's just do, I'll do this nice and slow. This is 2 to the 1 times 2. This is z to the 2 times 2. Okay, so that's going to equal 2 to the 2 z to the 4, which is 4 over z to the 4. All right, I didn't do anything with this negative 6. What should I do with the negative 6? I should bring it up. So 4z to the 4, z to the 6 comes up here, right? So our final answer is 4, z to the what? 10. Done. Don't put it over 1. All right. Oh, look at this one. Let's see. Lots of stuff in the parentheses, so let's do that first. Okay. 5 over 10, 5 over 10 equals 1 over 2. X to the negative 2 minus 7 equals x to the minus 9. Y to the minus 3 minus a minus 6, goodness, equals y to the positive 3. All right, so let's put that back together. Let's see, that was a 1/2. So that means the 2's on the bottom and maybe the 1 on the top. Let's see what else we got. We have a x to the negative 9, which means to make it positive, we should put it down here. And then we have y to the 3rd, which means it should go up here. And then the whole thing is still to the negative 1 power. So let me look at my key for a minute. Uh-oh. Did I do the one on the thing wrong? Let's keep going here. I may have done the one on the key wrong. I'll check. Let me do it again in just a second in another way. So this would be y to the negative 3 over 2 to the negative 1, x to the negative 9, which is the same as 2 to the 1, x to the 9, y to the 3. That's what I have on the answer key. So if you like doing it that way, do it that way, but there are other ways to do this one. Skip this part if you like the way we just did that. So some people like to go ahead and reduce this, and then they swap sides. So this is a 7, this is a 2, this is a y to the 3rd, y to the 6, to the negative 1, which means that all gets flipped around. So this would be y to the 6 to the 9th, y to the 3, which is still going to give you that. Okay, so that was just different ways to do that. Came up with the same answer, so I'm pretty happy with that one. I think I like the way I explained it first. Let me do that again. Let me explain that one again. All right, what's in the parentheses? 5 over 10 equals 1 over 2. Okay. X to the negative 2 minus 7, right, because it's a division, is x to the negative 9, which means that goes down here. And then y to the negative third minus a minus 6 is the same as negative third plus 6, which is y to the third, which means it belongs on top. And then because the whole thing's to the negative 1, it gets reversed. So y to the negative 3, 2 to the negative 1, y to the negative 9. So everything gets flipped, and you end up with that again. So that works. All right, this is a to the negative 5 times negative 4. B to the 2 times negative 4. That's going to be a to the negative, a to the positive 9. Sorry, that's a 9, and that's an a. Times b to the negative 8. So that means the a to the 9 stays on top, and the b, you can't even read that, sorry. A to the 9th, those are bad numbers together, and a to the, oh my goodness, sorry. That's a 9. Okay? Oh, no it's not. Oh, jeez. What'd I do wrong? Go back over here. What'd I do here? I clearly have a multiplication sign there, and I did not multiply. A negative 5 times a negative 4 is a positive 20 times b to the negative 8. Ugh. Okay. All right, scientific notation. Do this first. Put that in your calculator. 8.55 divided by 4.9 gives you 1.9. And then 10 to the negative 36 minus 9 gives you 10 to the negative 45. So this is 1.9 times 10 to the negative 45. I think that's the best way to do that one. All right, this one says, given the polynomial below, identify the leading coefficient. Now this is, I like to put them in order first. So the one on the test is probably not going to have the leading coefficient in the lead. You need to put it in the lead. That means find the one with the largest exponent, write that first, then write the rest in order of exponent. Okay. That would be if it was in order. Okay. So the degree of the polynomial would be 4th degree. The leading coefficient would be that. And the degree of the leading term would be that. Okay. But the rest of it is as is. So negative 5x4, negative 6x2, 6, negative 2x, negative 3x3. If you're unclear what it's asking on the test, just let me know. It's some sort of combination of this, okay? Degree, this one is a 4, that one's a 2. When you don't see an x at all, that's because the degree is 0. When you see an x with nothing there, that's a 1, and then that's a 3. Negative 5, don't forget the signs. Positive 6, 6, 6, that's a constant term, right? Negative 2, negative 3. All right, scientific notation. 1, 2, well, here, I don't know if you can see I did that right. It's here. I went 1, 2, 3 to get it at 9.51. I went 3 times. I went 3 times, and it was a really small number. Okay, times 10 to the 8th. That's how I would recommend to do that. 9.51 times, what is this here? This is 10 to the negative 3 plus 8. Oops. Equals 10 to the 5th. Okay. multiply. Okay, this looks, so all this here needs to be multiplied by this term right here. So 5 times 6 is 30. X to the 4th plus 2 needs to happen. Y to the 2. I'll come back to that. This one here, negative 15x to the 4th plus 1, y to the 2 plus 1. And this one here, negative 25x to the 4th, y to the 2 plus 2. All right, so this is going to be 30x to the 6th, y2, minus 15x 5, y3, minus 25x 4, y4. Let me check my key. That looks good. I will, let's see, let's do a couple more here. 5 times 9, 5.9 times 8.6. That is 50.74. 50.74 is 5.074 times 10 to the 1 power. And then 10 to the 11 plus a negative 49 or minus 49 equals 10 to the negative 38. So 5.074 times 10 to the 1. Wait a minute, I don't like that. 5.074 times 10 to the 1 minus 38 should be 5.074 times 10 to the negative 37. That's the answer for that one. All right, subtract the binomial from that binomial. From, keyword, out of order, y squared plus 5y minus 6y plus 7. Distribute that negative. Y squared plus 5y minus 6y minus 7. Add like terms. These are like terms. Final answer, y squared minus y minus 7. Okay. Multiply the following right in descending order. Identify the leading term. All right, so process first. 12s squared plus 16s minus 15s minus 20. That is 12s squared plus s minus 20. And the leading term is 12s squared. Okay. Simplify. Orders of operations. You are not allowed to multiply that before you handle this exponent. So negative stays there. 3 to the 3rd, w to the 12th. We are multiplying across the this little 3 here means we have 3 of these. Okay. When you add them up, you have 12. Right? And then you multiply by 1. This is a 9, by the way. So the negative, let's here, one thing at a time. Negative 9wn. So the final answer is, oh gosh, messed that up. What'd I do wrong? Why is that wrong? Why is that not a 9? Right there, 3 times 3 times 3 is 27. Gosh darn it. Negative 1 times, I got all wrapped up in the negative 1, 27w12. So negative 27w12. Okay. Convert. 1, 2, 3, 4, 5, 6, 7. 2.3 times 10 to the negative 7. It was a really little number. Divide, and then I will make another video here. All right, so the first term is going to be what? Negative 3c. Second term is going to be negative 2. Third term is going to be a positive c squared. That's a little tricky. All right, I'll come back and finish it.